combining, you're summing, a left and a right, you're summing two signals without any resistors in it, so over the long, the long term and course of time, something like this could cause damage. So, what we talked about one of the last times was using something like this guy that says it's a buffered adapter. So, if you unscrew this, you can see underneath the glue, you can see that little brown resistor in there that they have soldered. So they've got these little 10K resistors to be able to do stuff just like this, to be able to combine things, into one. So if we have to combine it, we want to use something like this or a summing box, or, if this was the only option, we wouldn't do this. We'd probably just run it in mono and just take one channel. So this was actually in a board plugged into the XLR jack, and on the back of the board I saw that there was another 1/4 inch line input. So that's the other thing we need to look at is, something like these amps, you've got, a mic switch down bottom, and then if you flip it up, you've got a line switch. So those are totally two different input levels. Your mic, for professional grade equipment is going to be at +4 dB, and your line is going to be at -10 dB. So, +4 being a hotter signal, this guy was plugged in to the mixing board and coming out. It was actually coming out of an audio extractor, which passes a little bit of noise. So it's taking the noise out of this guy, amplifying it at +4 dB going into the soundboard, into a mic level input, even though this is a line level source. So what I ended up doing was, removing it and taking a new 1/4 inch cable going into the 1/4 inch line jack, cleaned up the noise, sounded fine, and was actually the right level going into the mixer rather than going into a mic level input and a mic jack, and things weren't combined anymore. So just pay attention, when you're connecting things, when you're wiring up, just make sure we do it right. Especially with our company, we're unique in the fact that we give people 3-year warranties on our systems. Most people don't do that. But the fact is, we don't want to, be having issues, 2 years down the road or 4 years down the road because, we did some stupid thing.
We've seen it in less time. We've seen it in 6 months.
Oh, we've seen it. We've
less.
seen it in less than 6 months. Yeah. Which, to be honest, the times that we see that is typically our fault. We did something, and to be honest, it's when you leave. When you leave the office and you're going to a job site, if you know that you need to wire up something, you just either ask questions or just bring everything you can think of that you might need. And because stuff like this is like, okay, I'm on a job, I need to finish the job. Even though I was there yesterday, I knew I needed to wire the rack, but I forgot to grab an XLR-Y cable, so I'm just gonna, home make something, and that's when we get into trouble. Make sure you have the right parts you need. Same thing if we see something getting low on the shelf back there that we know that we use on a regular basis. Let Lucas know, let Mike know, hey, Warren, hey, we gotta order this stuff, because we're gonna use it. But don't just jerry rig something and because like I said, it works. It sounds good. It sounded fine. The only reason I noticed it is because we walked into church. And I hear a slight buzz in the system, and it's a brand new system. It's only been there a couple weeks, and obviously we shouldn't have a buzz through a brand new system. So something like that, how you would troubleshoot that is we ended up muting one channel by one all through the 16 channels of the board to find out where the noise was, and once it went away, then we could kind of see what was connected to that input and go from there. Make sense?
Yeah.
All right. Where am I? Speaker cable transmission distance as a function of conductor size versus loss.
Fancy. 3 times fast.
Pretty fancy. So basically, all the way in the left-hand corner, it tells you what gauge wire And then it goes over to tell you kind of the distance that you can run the speaker wire with that gauge cable without losing it, or how far you can lose it. So typically, when we wire up systems, we use a few different cables. If we're using a TOA and we're coming out a 70 volt output, typically we're going to use 18.2 for that. If we're using this crown or that crown to wire up a speaker like that, we're going to use typically 14.2. So 14.2, we're able to run at a longer distance, but with more wattage before we get drop off in the system. So the three big ones we use are going to be 14.2 for bigger speakers, 18.2 for something like this or like this, even like this on a 70 volt system. But if we've got a bigger speaker like this that we're using at 8 ohms, then typically for something like that we'd run 16.2. But as far as the cable we use, it's usually 12, 16, and 18. And you can see, in a 70 volt speaker as opposed to an 8 ohm system, I mean, you can run, using 18.2, I mean, you can run a 70 volt speaker a heck of a lot further than you can run the other guys, without having the voltage drop. And that's because, these are all transformer-based systems, which, regulate the voltage, and you can go a heck of a lot farther than you can with, trying to run from a power amp to a big monitor like that guy. What was that? Oh yeah, okay. Let me bring to this guy real quick.